Alright, so welcome to part 3 of the video lecture series on Introduction to Computer Networks. So we'll jump to the point from where we left off in part 2, and that is going to be slide number 20. Okay. So when we are talking about networks, the concept of networks is intrinsically related to how we are connecting to the network, and not only the network itself, but the network of networks, which implies the larger network. The most common example would be the internet. So the network nodes are connected via wired and wireless networks, and the part which allows the end users to connect to the internet is what we refer to access networks. So most commonly, there are 4 kinds of access networks. Residential access networks refers to the access network which is probably the most simplest in terms of the architecture, allowing home networks, neighborhoods, small offices, etc., to connect to the internet. Institutional access networks are slightly more complex, and they refer to larger networks, meaning where in the part where the end users are connecting to the internet, that segment of the network has a much higher number of terminals and network devices, and the institutional access network allows all of these devices to connect to the larger internet backbone. Next, mobile or cellular access networks are networks which are provided by mobile service providers, for example T-Mobile or Verizon. They have these broadcasting towers, and these towers are allowing the cellular connectivity for their users to connect to the internet backbone. Finally, satellite access networks are not limited to a smaller geographical area, but rather from a global perspective, where a device would connect using special satellite connectivity device and connect through the satellite to the internet backbone. No matter which access network you're referring to, all of these are defined by with respect to specific characteristics, and the characteristics of the access network defines how the end users or the end devices would experience the connectivity. The first characteristic would be the bandwidth, which implies the maximum allowed data per second that can be transferred through that specific media. It could be wired or wireless. No matter what it is, there is a maximum capacity and is defined as the bandwidth. The throughput, however, is related to bandwidth but not exactly the same, and the throughput defines the effective bandwidth. In other words, an access network, no matter what the bandwidth is, may actually have a much lesser effective bandwidth because of a much smaller capacity media which connects some other part of the network. So the throughput is the effective bandwidth that the terminal device experiences or is able to use. Finally, the media which is connecting the access network may be both shared or dedicated. Shared means there is only one path, that is one cable or one form of media, which is shared by all the devices or all the networks or sub-networks, which are smaller networks connecting to the internet backbone. However, on the other hand, the dedicated access network would mean that a path or that given media is dedicated for connecting that particular device or that particular access network. So computer media or communication media works with binary bits, which are zeros and ones, and this is because we know that computers and computing devices only understand binary bits. So the physical link is the actual physical media which connects the transmitter, that is the sender, and the receiver of this stream of zeros and ones for establishing the communication network. And it could be both wired or wireless, and we define media as, from a very broad perspective, two kinds. The first one would be guided, where we know the exact direction and path that this electric signal will take, and is common for any form of solid media. It could be copper, fiber, coaxial cable, so basically anything where we know the exact direction and path. On the other hand, unguided media is where we cannot specify the exact direction of the signal. That means the signal propagates, goes around freely in all directions and is seen with radio signals. So when we talk about wired media, probably the most common type of wired media is the twisted pair cable. It comes in both types as shielded and unshielded. If you look at the figure here, or the diagram here, the unshielded twisted pair comes as a bundle of wires, and it comes out as twisted pairs of cables. So altogether there are 8 cables twisted together in pairs, so there are 4 pairs. The shielded twisted pair has the exact same layout, just apart from the fact that there is a form of wrapper around these 4 pairs of twisted cables. The reason why we introduce the shielding is because it allows us to reduce the magnetic field interference when we are transferring bits across the network. So electric signals are interfered with any form of other electric fields which are around them because of the magnetic field that is generated from the electric field. And the shielding allows us to reduce that particular interference. So twisted pair cables come generally in 2 forms, Cat5 cables and Cat6 cables, with 2 different capacities. Cat5 cable, they range between 100 megabits per second to 1 gigabits per second, and Cat6 is the more upgraded version where it can go up to 10 gigabits per second. The next kind of wired media would be coaxial cable. This is probably the cable that you will see at home, connecting, bringing in the cable TV connection as well as internet connections if you have one of these coax routers. And as you can see from the figure here, it comes as a bundle. However, the cable has a form of wire mesh around a single wire which passes through the center of the cable. Coaxial cable allows us bidirectional communication, so it has popularity for providing broadband connection channels. Finally, the third kind, probably the fastest for wired media, would be fiber optic cable. And in this particular type of cable, it uses light as the transferring signal. So there are flexible glass fibers, which are basically thin strands of glass which are flexible, and it allows you to carry light pulses and also allows you to bend the wires. And the light signals passes through these flexible glass fibers and are interpreted as signals which can be referred as zeros and ones. They can allow very high-speed connections up to 100 gigabits per second. And the other thing which makes it very reliable is the fact that it has a very low error rate, which means that there is very less interference, because in both twisted pair and coaxial cable it uses electric signals, while in fiber optics it uses light, and light does not have any form of external interference. So it has a very low error rate and therefore is more reliable. And given the very high speed, it is common to see fiber optics connecting high capacity endpoints. For example, when you're connecting two large campuses, or using the institutional access network to connect your institution to the internet backbone. In wireless media, unlike wired media, the signal is carried through the electromagnetic spectrum using radio waves. And one great thing about radio waves is that it allows bidirectional communication, because it is inherently bidirectional in terms of the way that it propagates through air. So as the wireless radio waves propagate through the media, which is air, if we're talking about not intergalactic communication, the propagation is affected by three specific scenarios. The first one would be signal reflection. So if you have, let's say, a wall which is made up of thick concrete, and if you have a radio wave coming through air and hitting that wall, it will reflect in this direction. In case of obstruction by objects, this is not exactly reflection, but rather an obstruction of the propagation itself. So let's say if you have an object which is able to stop the propagation of the waves, and let's say you have the waves coming in like this, so this wave will now not pass through this particular object, while the remaining waves will go on propagating around it. So therefore we have this whole area where the radio wave was obstructed. In the third case, we have electromagnetic interference, and this occurs when we have a neighboring field of electromagnetic signals, let's say propagating from some device, and we have electromagnetic waves coming in like this, and because of this electromagnetic field, the incoming waves, they get modified in the way they can propagate. And this is a problem not only because it modifies the direction of the waves, but also it degrades the quality of the waves which are propagating through the media, and also the strength of the waves. There are four different kinds of radio links. Microwaves, which can allow up to 4 megabits per second channels, which is rather a small number for transferring a large amount of data. Wireless LANs, most commonly seen for wireless routers, they can allow up to 11 Mbps and 54 Mbps, and the more modern Wi-Fi routers, they are able to transfer a higher data rate. However, they fall within that same group of radio links. For covering a wider area with radio links, we generally use mobile or cellular technology. 3G, 4G, LTE, all these terms that you come across when you're using your mobile phone. And then you have satellite, which basically is even more wider range, and it has kilobits per second to 45 megabits per second channels. And as you can see, the larger the coverage area, the smaller the allowed data rate that you are able to achieve.